Yeah, so we were talking about the terrain types. Okay. Now the terrain type can be divided into three types. One is flat terrain, and the other one is rolling terrain, and other one is mountainous terrain. Right. So now I told you. I'm just again telling you just for the completion of the recording, right? So otherwise it is not going to be complete. So you see that yeah. Right. Now, a flat terrain is there are some threshold gradients. Okay, say it's some 4% or 6%. That depends upon the design standards that you are using. So Stroll is telling something, Astro is telling something, and Indian Road Congress is telling something, and we in Sri Lanka say something. Mix of all. Okay. So, but anyway, just to have an idea, just think if it is a flat terrain in the sense now everybody has gone to Kandy. If you are going from Colombo to say somewhere around Varakapola, it is just flat terrain, and from Varakapola to Kegol, it is rolling terrain, and then from Kadugannawa, yeah, Kadugannawa in the sense down from down the gradient to up Kadugannawa down. So you may call it some mountainous terrain, and also in Habutale area, Bandaraville area, there are mountainous terrains. Okay, why this is important? Because the design strategy is different for these three terrain types. For flat terrain, it is one strategy. If it is flat terrain, the amount of super elevation that you are going to apply is lesser, and in the rolling terrain, it is in the middle, is something like that. And after that, the mountainous terrain, you can go for very tight super elevation, say something like 8%, 10%. I have seen in Bandaraville area sometimes you have 12% super elevation as well. Okay, now in Sri Lankan conditions we don't recommend 12% because we are using Ostros. Our maximum super elevation is 10%. But anyway, Astro recommends 12% as well. So that is why they are bit important, right? Then the other thing is this design vehicle. Now design vehicle, of course, we have to, before designing a road, okay, we have to have a design vehicle. That is not for each and every road, right? But as a concept, for a country, you have to have a design vehicle. For which design vehicle you are going to design your road, right? So it may be something like, say, that can be P design vehicle. That is a passenger car. So that means your national roads are designed for passenger cars. In that case, maybe a lorry will not find it easy to travel in these roads. Why? It is designed for the small vehicle, right? Now Sri Lankan roads are usually designed for SU design vehicle, or that is single unit truck. Single unit truck is the normal truck that you see on the roads. I'll show you that. It's this one, SU design vehicle. This is what we call the SU design vehicle, or single unit truck. So that means national roads, when they are being designed properly, a single unit truck can travel without any problem. Okay, but not WB40 or a long vehicle. Now some roads, especially in countries like America, they are using their design vehicle as WB40. That means in their roads, these vehicles can travel without any problem. So what is this problem that you are getting? Now just think now for a single unit truck, if your gradient is something like 4%, 5%, it doesn't go into crawl speed. What do you mean by crawl speed? It is just it is in a very small speed it is being traveled. Now in our country, for the design national road, now you have to think about this, because otherwise what happens, in most of the roads in Sri Lanka are not designed. That's the thing. Now, design in the sense they were not designed at the beginning. So what we did was, there were some roads, we went and put some macadam there. After that, then there came the designs, so we don't have a very large budget. So what we are doing is we are just trying to improve it. Okay, so it doesn't mean that they are being designed into the proper design standards. Okay, so maybe that you might have seen. Of course, some we have done. Now, as an example, if you do you remember that Hattanurali road? Earlier, it was a macadam road and very sharp bends and things. So we did some improvement there. Okay, but it doesn't mean that it has been designed into a very advanced design standard. Okay, so you cannot travel at 100 kmph or say 70 kmph even. So maybe the design speed or the speed that you can travel is 30. But still with 30, it is safe road. Earlier, even for a driver who is traveling at 30 kmph, the road was not safe. But now, maybe you can travel at 30 kmph, it is safe. And in some places where we have provided enough space and enough side distance and things, you can travel at 40 or 50 speed. Okay, now remember how we are doing the designs here in Sri Lanka. Is it wrong? No, it is not wrong because engineering is always budgetary. Okay, you have to think about your budget as well. Otherwise, if you are going to go for a very advanced design and you don't have money, that is not engineering. Okay, and that is just a little bit about design speed. Design speed is of course a speed that you usually select and you expect at least 80% of the drivers 80% of the drivers will run below that speed. Okay, that is what you call design speeds. Now just think that you are going to design a road for 40 kmph, but most of the drivers they are trying to travel at 70 kmph. Then whose fault is this? Drivers or designers? Because the driver doesn't know or driver doesn't have an understanding which design speed is being designed. Either you have to post it. Okay, you have to post the speed. This is your speed. But the only thing is now, practically speaking, what drivers do is, you know, as human beings, when they are trying to drive, they try to understand whether it is safe for me to travel at this speed. If they feel it is safe, they will go. Otherwise, they don't. Now, I am talking about a driver who has the sanity and who is not under the influence of drugs. Drugs in the sense it can be narcotic or uh, narcotic or medicinal, whatever. Okay, so that means he might have used liquor, that's one thing, or otherwise he might have got some tablets, but still the effect is there. I'm not talking about these people. I am talking about the people who are naturally healthy, and I'm not here talking about the trainers or very old people. I'm talking about an average driver. So he will try to say, okay, I'm traveling at 80 kmph. Is it safe? If it is safe, he will try to travel at 80. But the problem is, if you have designed it for 40 kmph, it will be pretty okay in the straights. But the problem is when it goes to the bends or the curves, then there comes the problem. So we'll discuss what happens in the bend after few minutes. And these are some cross sections that we are going to provide. So that is based on RDA standards. Now that depends on the design volumes PSU per day. This is the maximum PSU per day that is being considered, 72,000 to 800,000. So road class is A, so the design speed should be 80 to 70, something like that. Okay, and here depending on the design volumes, of course, you can go for the design speeds and things. That is just one guideline to select the design speed. Yeah, so these things that of course I am not going to cover. Planning of a new highway. So everybody knows there are four phases, that is called a study, preliminary survey, reconnaissance survey, and detailed survey. So this is how we are planning a road. Okay, so that is not much relevant to our task here for the design. Okay, these are just for your information, so you can refer. And level of service also, that is something that you have to understand when you are going for design. But for our computer highway design, it is not that relevant. But anyway, if you are going to go for a design, you have to think about the level of service. Now the level of service, there are six phases from A to D, sorry, A to F. Now this is how it is being uh, defined, right? So this is something like free flow, that there is only one or two vehicle. And this is service B, reasonably free flow. And then the stable operation, that's C. And when it comes to D, borderline unstable. But anyway, uh, you are designing a road such a way that at the end of your design period, it has to reach level of service D, not E or F. That means if you have designed a road for 10 years, at the end of 10 years your traffic should be like this. It has to come into level of service D. Don't go for level of service E or F. That means the road has failed. Okay. So these are some equations, how to find the service flow rate and level of service. Yeah, okay. Now we'll discuss a little bit about highway components and the class of roads. You know there are how many classes of roads in Sri Lanka? A, B, C, D, E, five classes. Okay. Now A and B class are usually handled by RDA. Okay. And exceptionally CMC. Why is that? Because CMC is having a very large engineering staff, so they decided, okay, we are going to do our stuff. So we gave away, and now again we are trying to grab them back. Okay, now we have grabbed, the baseline road and Sri Javadhan road as well, and Marine Drive also we are doing something. You see, huh? Gold Road, yeah. So that is what we are doing. But anyway, most of the things are being done, maintenance and things, they are being done by the CMC, right? And then other A class stores everywhere, even if it is Candy, Gold, Badulla or Jaffna, all are being handled by RD. And then B class roads are being handled by RD alone. Now A class road are these arteries, that means interprovincial and things. B class roads are interdistrict roads, or what you are going to feed A class roads. And C class roads are being handled by provincial councils. But still, you remember in C class roads also, there are bus routes. Okay, so buses are there. And D is of course being handled by Pradesh Sabhas and urban councils. And earlier there were some E class also, the gravel roads. But now we don't have any such gravel roads being handled by Pradesh Sabhas. Therefore, we put this E into expressways, right? So E class is the expressway. And we'll quickly go through this the components of a highway. Okay. So there is something called center median, that is in the center. So usually you are having 1.2 meters width. And why there should be a center median? Center median is there. Center median is there because we want to separate the two flows of traffic in opposite direction. That is for the safety, right? Now usually for all all new four lane roads, we try to provide center median. Okay. But the problem is, now in Colombo area, sometimes we have 4 lane roads without center median. So they are not very nice, okay, because there is a contra flow, and there can be ill-disciplined drivers who are trying to encroach the other side of the highway, and that is very dangerous. Okay, and remember, you can provide a shoulder center median only if you are having at least 4 lane road. So 2 lane roads don't provide center medians. Huh? That is not very proper. Okay, and hard shoulder is this. At the end of the lane, there is something called hard shoulder. You call it hard shoulder come bicycle lane. Okay, so there can be that can be utilized for bicycles as well. Okay, soft shoulder is this area where you are having the soft shoulder. They can be either turfed or what else you can do for soft shoulder, or it can be gravel itself. Okay, sidewalks, in these are for pedestrians, so it should usually be 2.5 or 3 meters, but for extreme cases we go for 1.5 as well. Pedestrian crossings, and these are some parking types. So there can be parallel parking, perpendicular parking, and angle parking or echelon parking. And these are some road signs and markings, right? Okay, so surveying, of course, you can read how you are going to do the topographic survey. What I have provided you is a survey that has been done according to these standards. Okay, so that is what you call Piliandala Moratuwa survey. This is an actual project. Design was done by me. Now it has been constructed. You can see there. And anyway, we are going to design it today again, right? And then side distance, of course, you have to have a little bit of understanding. Side distance is the unobstructed distance that you can see in front of you when you are driving. Okay, and it is usually composed of two lanes. One is reaction distance, this is a braking distance. Reaction distance is once you see some obstruction in front of you, now you see that with your eyes, and your eye sends a signal. Okay, you have to stop it, you have to stop the vehicle, and your brain orders your leg to press the what? Accelerator. Huh? Or the brake. No, some do when they are practicing, okay, there's something there. Okay, apply brake, then what happens is he presses the accelerators to the bottom. Okay, so that's it. But anyway, so just to understand that uh, I have to press the brake pedal, not the accelerator. That also takes some time. That is why there's a reaction time. Okay, so it is usually we take it as 2.5. You can without going for highway engineering theory, everybody has learned physics. You go for S equals ut plus half at squared. There is no acceleration. A is 0, so S equals ut. Now you just think t is 2.5 seconds. U is say 100. Now just calculate how many meters you are going. Okay, just to take the decision. That is why the side distance is important. Okay. Now side distance is of course there are three parts. One is stopping side distance. That was what we were talking. And then we are having overtaking side distance. So overtaking side distance is, just think, now this person, now B is traveling in a lesser speed. So what A does is A encroaches the other lane, opposite lane, and then he goes in front of that, in front of the vehicle B. Now to do this, there should be some physical distance available in front of you. Otherwise, that is why I say don't overtake at the curves. Okay, but that is a general thing. But if the curve is having side distance, then okay. Now I remember that one day when we were going to Jaffna, our driver was somewhere around year 2010 or something. Okay, so our driver was overtaking in a bend, and in the bend they had the dash line. Okay, but there was a police officer and he stopped, and he said in the thoroughfares ordinance there is a clause, you cannot overtake in the bends. Okay, so I was wondering which clause was that. Okay, there is no such clause in thoroughfares ordinance about driving. Okay, so we told them. Okay, there were two engineers, so we told them in thoroughfares ordinance there is no such thing. If you are having these dash lines, you can overtake. So you can't be there in the bend and catch the people. So that is illegal. Okay, so in our case, the people generally think you should not overtake in the bends. No, you can overtake as far as the proper side distance is there. But if there are no side distance, if you have the continuous line or the double line, you cannot overtake. Now, what IRSTM division is doing is, now depending on the side distance, they give the road signs and markings. If there is side distance, they give the dash line. If there is no side distance, so they will decide on the double line or the single line, right? So it is better if you can provide overtaking side distance as far as possible, but side distance, stopping distance should be everywhere, otherwise it is dangerous, right? And the other one, continuation side distance, is here. Here we assume that the overtaking vehicle is already in the other line, other lane. Now he has to take a decision whether to overtake this or not. For that, there is some distance necessary. Okay, that is uh, what you call the continuation side distance. So it is usually taken as twice the stopping side distance. Okay, right. Then horizontal alignment. Horizontal alignment means usually we are having here for national roads tangents and curves. We don't use tangent curves for national roads. Tangent curves usually we use for expressways. Okay. Now this is a simple theory, when vehicle is traveling in a curve, what happens is there is a centrifugal force acting. Okay, now by elevating this road surface, what we do is we are assisting the friction with component of gravity to balance this centrifugal force. Okay, with that we have come up with an equation. This is the equation, so we are modifying it as so this is the minimum radius. So you have to give, yeah, for a given design speed, for a given super elevation, and for a given friction factor, so there should be a minimum side distance, sorry, minimum radius. So side friction factors, of course, uh, yeah, side friction factors, of course, you have to get to the research, right? So unfortunately we haven't done these researches. Okay, so what we are using is the Australian standards. So I'm really happy. Thankfully, some 200 years back, so white people, they thought, okay, we'll go to that desert island or the the continent, and we'll conquer it. Otherwise, if they didn't go there, you know what will happen. Then, of course, what we have to follow is the design standards of UK, Canada, or America. So, which are totally different from ourselves. Does that mean that Australian standards are almost tallying with Sri Lankan, sir? No, they are not tallying almost. But still, it is better compared with AASHTO, Canadian standards, or UK, right? But now, of course, Indians are doing very well. Right, so Indians are doing better now. Indian Road Congress is coming up with so many design standards now. Usually we use the HCM. What is that? Highway capacity manual. Which country is that? Have you heard about highway capacity manual? Highway capacity manual is it is American. Okay, so you know for this the signal calculation and things, and for the level of service, all these things we are calculating. We are using highway capacity manual. That is the American version. In year 2017, the Indian Road Congress had their own highway capacity manual. So that is more relevant to us than the American one. Okay. But anyway, what we have to do, what we are supposed to do is we have to get these side friction factors through our own research. Okay, so then finally this is where I wanted to come. Here there is design speed, because since this is not a theory class, I am not going to go into much detail. So here there is the design speed, then this is super elevation, this is the curve radius, minimum curve radius we have to give. As an example, you think you are going for 50 kmph design speed and your super elevation, you are trying to provide minimum is 4% because it's a flat terrain, then the minimum curve radius you have to give is 95. Okay, something like that, you have to remember this. And adverse crossfall is, if you are going to give a radius greater than this, you need not to provide super elevation. Okay, yeah, I think this theory part is now we have to think there are types of curves that also we have to do. Simple curve, transition curve, of course we are not using in this series. Compound curve is two curves in the same direction but the radii are different, and the reverse curves are two curves in the opposite direction with different radii, or can be similar radii as well. Similar curves are something like two curves in the same direction connected with a small tangent. And there is something called widening also. This widening is because if this curve radius is narrow, then vehicles are trying to encroach the other lane. Okay, so this is a place where curve widening is provided. That is this is in, I think, Ginigathen Hatton Road. Okay, so anyway you need not worry, the tables are given. Right, so now of course we have to stop for the tea. How many minutes? 20? 10 minutes. Yeah, so we'll stop this class for 10 minutes. Now it is 10:30, 10:25. We'll meet again for at 10:35, right? Right, we'll discuss a little bit about super elevation. You know, super elevation is that slant in the road like this. Okay. So why it is necessary? Because there is some centrifugal force, right? That is why super elevation is there. Now this is how super elevation is being developed. So earlier, at the beginning, it is normal ground like this, and then now this is, what is this direction? This is clockwise direction. Okay, if the clockwise direction is there, you have to elevate the LHS side. Now, do you remember in our childhood, usually there is a game that we play. What do we do? We tie a ball and then we rotate it over our head. Okay. Then which side is the force that you feel? Towards the center or outside center? Towards the center, just because that you are having your, but the string, the force is outside. Force is outwards. Only thing is to balance it, you are having string and there's tension in the string. Okay, so this force is outwards. So that is why what we do is we slant this outward direction. Then what happens is there comes a gravity component to balance this centrifugal force. So this is how it goes, right? Then there comes the maximum, the full super elevation, and then again it reduces back into the normal cross fall. So that is what is happening in a simple curve. Okay, so the super elevation standards, there are two methods to calculate: relative gradient method, and the other one is rate of payment rotation method. Then what happens is, you have to calculate using both these methods, and then you have to get the maximum of super elevation development length. But I can just tell you a trick. If your design speed is lesser than 80, always you have to use this equation. Okay, relative gradient method. You have to consider the rate of Feynman rotation method only if the super elevation development, sorry, the design speed is greater than 80. Okay, then now today we are not going to design super elevation using the civil 3D, but at home please try to read this part 10.5, because these are some jargon, I mean some terminologies you have to understand, otherwise you will not understand what is happening in civil 3D. Okay, these BFS begin full super, then begin normal count. So I'll just show you. Say this is a super elevation development. What happens now? There is we are back, I think. Okay, right. So super elevation development. This is how it goes. Okay, now it is minus 2.5. From minus 2.5 to some value. This can be whatever that is greater than 2.5. If it is 2.5, it is coming here. There is no such shape, because then the the RHS side, there will be no such reverse crown like this. Okay, if it is 2.5, but if it's greater than 2.5, of course you are going to get a reverse crown like this. So these are the equations to calculate these critical points, and this is for the reverse curve. Can you see that super elevation is being uh, the side of super elevation is reversed. Okay, and this is closed space reverse curve. Now the super elevation development, however, this point, that is the level point, is coming to the proportionately between these two curves, and closed space compound curves, depending on your curve radius, the super elevation changes. Anyway, you need not to worry about super elevation or super elevation development, because I am going to give you a macro enabled Excel sheet to calculate super elevation. So that means you can calculate super elevation for Sri Lankan standard using that Excel sheet, right? So as far as you are here in Sri Lanka, this super elevation method will work. But if you are going to go to Middle East or Australia, it will not work, because their standards are bit different. Okay, so you have to know how you are going to calculate uh, manually and using the software as well. And finally, we'll come to vertical alignment. Now what you have to understand about vertical alignment is, in horizontal alignment we are having straights and horizontal curves. Here we are having vertical curves. The vertical curves are parabolic. Horizontal curves are, of course, circular, right? And there are two types of curves in vertical alignment. One is crest curve like this, and other one is sag curve. Okay, now for the if you are going to consider the crest curves, again you have to consider side distance. Side distance, of course, you can calculate. Other thing is, you can, there is something called k value. K is LV over A. LV is the length of the vertical curve. A is the gradient difference. So that means, there are two gradients coming, right, like this. Two gradients coming, and the gradient difference is there like A. The curve length, say 50. 50 divided by then the gradient difference, it is the k value. Okay, so this is the minimum k value that you have to provide. If you are going to go for 50 kmph, for the stopping side distance you have to provide 9.8. Here please correct this. This is CST SST stopping side distance, then continuation side distance CST, and this is overtaking side distance OST, right? So if you are going to provide minimum stopping side distance, your k value should be greater than 70. And then these are the minimum curve lengths depending on the appearance criterion, and this is the k value depending on the comfort criterion. These are necessary when it comes to designing the the vertical line. And for the these are sag vertical curves, right? And for the sag vertical curves, the governing distance criterion is headlight. Okay, so this is how you see the road at night. Okay, because at the daytime everything is visible. Okay, no problem. But when it comes to night time, that depends upon your headlight criterion. Okay, so there is an equation for this as well. And on overhead obstruction criterion. Okay, and the grades, of course, what you have to think are these are the maximum gradients, right? If it is A class road, if you are going in flat terrain, it should be 4% maximum. If it is rolling, 6%. If it is mountainous, 8%. Likewise, you have to calculate. Now, you have to consider these things. And the minimum gradients is what you have to think is it should be sorry, it should be usually 0.3% minimum gradient should be given. Otherwise, there will be drainage problem. Okay. And grades steeper than general maximum are sometimes used where necessary. Okay, so you can read these things, right? And finally, the harmonization. It is at the end of the vertical alignment. So at the end of the design, what we are doing is, uh, of course, horizontal alignment and vertical alignment are two projections of the same road. Okay, horizontal alignment is projection to the horizontal plane, vertical alignment is projection to the vertical plane. Finally, anyway, what happens is finally it's the same road. Okay, so there should be harmonization. Okay, so here can you see this is a poor combination. Okay, this is you call it hidden dip. Okay, you don't see that. So what happens? The vehicle is going this way, and finally have you seen that night rider driving like that is going like a projectile. Okay, so that is not very good. So that is why we have to avoid this kind of alignment and plan and profile. Right, that's all about the theory part that I'm going to cover. How many hours we took? 1.5 hours. Okay, right. Then we'll go to our civil 3D. Now, right. Now, of course, please make sure that you are having Civil 3D installed in your computer. And I am going to use Civil 3D 2023, that is the latest version. And whatever you are having above, say, something like 2015 is okay. Okay, if it is at least about 2018, that is very much okay. Okay, but don't try to do with Civil 3D 2010 or something. It's not going to work, right? And we no more use them, right? Then we'll start Civil 3D. Okay.